Dear students, today I am going to start the chapter limit of a function. Limit of a function is a new chapter in class 11 and you have to understand the chapter properly because this is new in mathematics also. And before starting the actual limit, I am showing you from where the concept of limit has come. Okay, limit of a sum, limit of a function. Consider a function f of x is equal to x square minus 1 by x minus 1. When we try to find f of 1, at that time what will happen? 1 square minus 1 by 1 minus 1. We check 1 minus 1 by 1 minus 1 is equal to 0 by 0. And 0 by 0 is always undefined. This is undefined. You cannot say what will be the value of 0 by 0. Therefore, this shows you that when x is equal to 1, then f of x is indeterminate. But if we consider x is equal to 1.0001, at that time the value will be f of 1.00001 is equal to 1.00001 minus 1, 1.00001 plus 1 by 1.00001 minus 1. And that will become your 2.00001. That means exists. At x is equal to 1, the value is indeterminate, but when I am taking x is equal to 1.0001, at that time I am getting value. Similarly, x is equal to 0.99999. This will be 1. At that time value will be your it will become 0.0009. This value you locked in. That means here also the value exists. From this concept, that means when x is equal to this one, that means 1.00001 or x is equal to 0.99999, at that time we are getting values, but when x is equal to 1, there is no value. but x is equal to 1.00001, f of x is equal to becoming your 1.00001, and when x is equal to 0.9999, f of x becomes 0.9999. But we are not getting any value at the place of when x is equal to 1. The neighborhood points, at neighborhood points, of 1 we are getting the value, but at x is equal to 1 we are not getting value. This concept arises the concept of limit, and this thing is also used in many fields of science, that means your physics, in chemistry, and also in economics also. This concept of limit is very much important. Now I will show you what is the meaning of x tends to a, because in limit most of the place you will see that x tends to a, or x tends to a plus, x tends to a minus. What are their meaning? That you check now. I have taken x tends to a as the point x equal to a is this point, and x plus 1 is this one, b1, and a minus 1 as a1. And similarly, gradually we are going towards x equals to a. You check this one, a minus half, a minus 1 by 4, a minus 1 by 6. That means finally we will reach up to x is equal to a. Similarly, from a plus 1, from b1 point, b2 point is coming a plus half, p3 is a plus 1 by 4, and b4 is a plus 1 by 6. And finally we will reach in the point x is equal to a. That means this one subtraction and this one is addition. The subtraction place is known as x tends to a minus, and the addition plus is called a tends to a plus, or in some books it is written as x is equal to a minus 1 and x tends to a plus 1. Okay. Here another meaning of, suppose x is equal to 1 or x tends to 1. What is the meaning of this? X is equal to 1, this one point. I have drawn the number line. Let this point is equal to 1 minus half. This one is your a1 point. This one is your 1 minus 1 by 4 a2. This one is your a3 and 1 minus 1 by 6. Similarly, a4 is 1 minus 1 by 8. In that way we are reaching to x equal to 1. Similarly, this point is your b1 and this is 1 plus 1. This point is your b2, 1 plus half. This point is your b3, 1 plus 1 by 4. This point is your b4, 1 plus 1 by 8. This one is the increasing side, this one is the decreasing side. That's why this part is known as x tends to 1 minus, and this part is x tends to 1 plus. In earlier sum, at x is equal to 1, f of x, when x square minus 1 by x minus 1, it was 0 by 0, undefined. but we was getting the value in these places when x is equal to 1.0000 0.9999. At that time f of x was 0.9999, but when x is equal to 1.00001, at that time f of x was 1.00001. This proves that we are not getting value at this place, but we are getting value the nearby points, the neighborhood points. This part is x tends to 1 minus, and this part is your x tends to 1 plus. That is the meaning of 1 minus, x tends to 1 minus, and x tends to 1 plus. I think you have got clear about x tends to 1 plus and x tends to 1 minus. Now I will give details about limit x tends to 1. In some book you will get like this, or in some book lim x tends to 1, or in some book LT x tends to 1. All are same thing. All are same. What is the meaning of this limit x tends to 1? When x is equal to 1, I can divide in two parts. One is negative side, one is positive side. In negative side, the nearer points of x equal to 1 are x equal to suppose 0.9, or x equal to 0.99, 0.999, x equal to 0.9999. In that way, in this place x equals to suppose 1.1, x equals to 1.01, x equals to 1.001, x equals to 1.0001. These points I have considered. This side is known as your x tends to 1 minus, and this side is known as x tends to 1 plus. That means when it is given limit x tends to 1, that can be divided into two parts. One is limit x tends to 1 minus, another is your limit x tends to 1 plus. This side is known as your right hand limit, and this side is your known as left hand limit. So from this discussion we have understood that lim or limit x tends to 1 means it will be always divided in two parts. One will be limit x tends to 1 minus, another will be limit x tends to 1 plus. And one more thing here you have to understand, that the difference between 1 and 0.9, 1 minus 0.9 is your 0.1. This thing taken as delta. This thing taken as delta. Similarly, 1 minus 0.99 will be your 0.01. Delta is here, this. This delta, that means x minus 1 and its mod is always less than delta. In that way you have to consider the value of delta. Delta is very small, you have to consider delta as small as possible, because if delta is more, then your difference will be more. Clear? If delta is more, delta is very important. The difference I am taking very less, that is 0.1 or 0.01. In that way, here the delta will be your 1 minus 1.1, that is 0.1, 0.9, and 1 minus 1.01 is your 0.09. In that way, these are delta. And one thing important, x minus 1 that and its mod should be always less than delta. That means that gap you are taking between the points should be as small as possible. That is very vital. Try to understand all thing. Now I will show you the difference between limit extends to a f of x and f of only f of a. What is the difference between this one and this one? Just now I have discussed limit extends to a f of x can be derived in two parts. One is right hand limit, that is limit extends to a plus f of x, and another one is limit extends to a minus f of x. A plus and a minus. A minus means it is gradually decreasing, and a plus means it is gradually increasing. One example I have shown here, that you check f of x is equal to 2x minus 3. 2x minus 3. Suppose we are going to find this part. Limit extends to 2 f of x. For that I have found the values of x when x is 2 minus. That means x is gradually decreasing. That means 1.9, 1.99, 1.99, 1.99999. In that way I have taken values. And if I increase the values, this will be near about 1. It will be going to nearer to 1. And when I am taking 2 plus, that means more values of 2, that means 2.1 gradually increasing, 2.1, 2.01, 2.001, 2.002. To check the values, 1.2, 1.02, 1.002, 1.00. That means it is gradually, the value of f of x is gradually decreasing. This one will be also somewhere become 1. If I increase the values of x, it will be also nearer to 1. That means finally I can say that limit x tends to 2, f of x is equals to 1. In both cases, left hand limit and your right hand limit, both the values are nearer to 1. That's why limit extends to 2, f of x will be 1. And what happens to f of 2? F of 2 will be 2 into 2 minus 3. That means 4 minus 3, that will be 1. That you check f of 2 and this limit value will same. That means f of 2 also giving me 1, and this limit extends to 2 f of x is also becoming 1. Now this gives you the actual definition of limit, when limit exists and when limit does not exist. That is very important here. Now I will show you formula wise when limit exists and when limit does not exist. Limit will exist when your limit x tends to a minus f of x is equals to limit x tends to a plus f of x and is equals to f of a. What value you are getting in your left hand limit? This one is your left hand limit, this one is your right hand limit, and this one is your value, at the point. When all three are equal, then limit exists. When limit does not exist, if suppose limit x tends to a minus f of x does not exist, that means it is giving you infinity. Or limit x tends to a plus f of x, this one also does not exist, that is infinity. Or f of a does not exist, at that time limit will not exist at all. And one thing you remember, limit does not exist when it becoming infinitive. 0, suppose you are getting limit x tends to 2 f of x is equal to 0, that means 0 also limit exists. 0 is a value. 0 is a value, that means limit will exist, but infinity is not a value. That's why if infinity comes, then limit does not exist. Now I will show you another example. Check whether limit x tends to 4 root under 4 minus x exists or not. Here also two parties coming. One is your left hand derivative, left hand limit, and your right hand limit. That means limit x tends to 4 minus f of x, 4 minus root under 4 minus x, and another one is your limit x tends to 4 plus root under 4 minus x. You have to find values x and f of x. Suppose I am taking 3.9, 3.99, 3.999 in that way, and this one x and f of x as your 4.1, 4.01, 4.001 in that way. This will be root under 0.1. This will be your root under 0.01. This will be your root under 0.001. This will be your root under 0.1. Root under minus minus 0.01. Root under minus 0.01. These are all imaginary values. Root under minus 0.1 is imaginary. That's why value does not exist. But here value exists. Thus, limit x tends to 4 minus root under 4 minus x exists, but limit x tends to 4 plus root under 4 minus x does not exist. Therefore, limit x tends to 4 root under 4 minus x will not exist. once again I am repeating, that means I have given limit is limit extends to 4 root under 4 minus x. I have divided in two parts, one is right hand limit, left hand limit. Left hand limit I have taken the values gradually decreasing, that means 3.9, 3.3, 3.99, in that way I have got the values, that means left hand limit exists. But in case of your right hand limit, when I am taking value, root under negative term are coming, that means this is imaginary, that means right part does not exist, and the left part exists but right part not exist. This proves that your limit extends to 4 root under 4 minus x will not exist. I think you have understood the whole thing completely. For today's class, this much. And like and subscribe my channel if you find that these are helpful to you. Okay.